This is the last section of 2.1. I know it's been a lot, but hang in there. What I start to look at, and this is pretty interesting, this isn't an exact science, but it's pretty close from the data that I've collected. And we'll talk about this later on when we do linear regression. But I can calculate miles per hour based on how far you throw it. So I have 120 feet, it's 50 miles an hour, 360, 100. In statistics, and this is going to be my x variable, this is going to be my y, we call this the explanatory, and this is our response. We're looking for miles per hour, so that's why that's my y variable, which is my response. And right here it gives me the linear regression model. Where did I get that? From my calculator. First, again, I go in, and I always look at, and that's why you're wondering earlier, maybe why do you use L3 and 4? Well, L1 and L2, I put this data in there. And just like anything else, I always want to get a picture of it. So I'm going to go in here, and I've done all sorts of things in my calculator, so bear with me a minute as I turn off a few of these. We will need them again, but for now, and I got all sorts of stuff going on. And you start to see, and if you're doing this with me, what I'm going to do is I'm going to go second y equals, I want to turn this only one plot on, and what I'm going to do is I'm going to do a scatter plot, which is this one here. So I hit enter, but this is going to be L1 and L2, so I do second L1, or actually it's going to be L2, L1, because I even put those into my I put my x variables second. Then if I hit graph and then I hit zoom 9, that always centers everything up, puts things. Look at this, it's almost a perfect straight line. So I can use a linear model to represent this data. And just like anything else, I always draw a graph to see if my data, what it looks like. And in this case, a linear model looks pretty good. So what I do is I do stat calculate, and down here it says linear regression. This one's reserved for statistics. This one you may have done for algebra. And the only difference is they use A to represent the y-intercept and B for slope. I don't know why they change it, but they do. So we go to number 8, and I said that x's were L2, they were L1. Frequencies, I'm not having any in this particular case. I hit enter, and there it is there. There's the equation, that's where I got it. And you'll see later on, we'll learn about these two numbers. They mean something to us. If they're not on your calculator, I'll show you how to turn them on another time. This means that a linear model is pretty good representation of the data. Alright, so then after that, well, now I have this data, and we know what it looks like. We know that the data itself is symmetrical. So I'm just going to use box plots to graph it, because I think they're the easiest to show. So I'm going to go in and I'm going to graph a box plot using that data. So all I'm changing here, I'm going in here, and I'm not going to show outliers because I know 109 is an outlier. I'm really not concerned about the outliers right now. I just want to look at the data itself. And I am going to look at, I have L2, L4 graph. Whoop, that's not it. Let's go back in, stat, enter. Let's look at my data. Which graphs am I looking for? I'm looking for L3 and L4 is what I want to graph. So zoom 9, you'll just spread it out a little bit. There it is there. That's what my data looks like. You see how symmetrical it is. Well, sometimes what happens is, we're going to talk about transforming data and what happens if we were to add a constant to this. Well, I realized after I did this that maybe these readings were off. We were throwing from the wrong spot. We weren't throwing from home plate. We were up the line a little bit, and they were 10 feet off. So I'm going to subtract 10 feet from every single data value. And what happens to my distribution? Let's see what happens when I subtract 10 feet from each of my data points. So I go back in, and I know I already have it set up to do this. If you go in here, and what I did was up here in L5, all I did was L3 minus 10. So I do second L3 minus 10 and hit enter, and it puts all that data in there. I'm going to go in and I'm going to graph it. It's already graphed here. I have it all set up. I just have to turn on the graph. And I'm going to compare it to the other one. Again, hit zoom 9 so everything falls in within your screen. You see everything, it's the exact same distribution, same shape. It looks exactly the same, except everything, this center was shifted down to the left. It has the same range from here to here as this one. It has the same IQR in here. So what do we know? Its shape stays the same. Its measures of spread stay the same, but its center changes. So if we add or subtract a constant to a distribution, that's what happens to it. Well, what happens if we multiply it? Well, what if I want to convert this, instead of doing it as feet, all of a sudden I just want to do this in meters. So I multiply by a constant. And I have that constant somewhere. I know it's like 0.6 or something like that. I forget where I wrote it down. But let's go in. I already did it. And I changed it here. And you'll see what happens. I multiplied all my data by a constant. And I hit graph and zoom 9. So look what happens. The shape stays the same. But it got a lot small. This got a lot smaller. This got smaller. Everything got smaller by the constant that I multiplied everything by. So I multiplied every piece of data by the same thing, and everything got smaller. The shape's the only thing that was unchanged. So, and the same thing would happen if I converted this to miles per hour, how I did it. If I want to do that where I'm adding a constant and subtracting with that formula that I calculate, the linear regression formula I found. If I wanted, when I converted it, what did it do? Well, it changes. It's going to shift it and shrink it, or shift it and make it bigger, whatever it does. But it doesn't change the shape of the distribution, no matter what I do to it. And that's about converting distributions, adding a constant, multiplying, and dividing. That's it for this chapter. I hope you enjoyed it. Not this chapter, this section. I'll see you at the next one. No.